Good morning, good day, and good evening to all our attendees joining us for today's latest Data Science Central webinar. I'd like to start our event off today by thanking Hortonworks and Revolution Analytics for sponsoring today's event. Hortonworks is a wonderful supporter of the Data Science Central community, and we are honored to have them sponsoring today's event along with Revolution Analytics. I would also like to take this opportunity to mention and to show our appreciation for some of our other recent sponsors, including Teradata, Tableau, TIBCO Streambase, Splunk, and LavaStorm, to name just a few. These past webinars are available on demand at datasciencecentral.com, and if you have not had the opportunity to view them, I would encourage you to take a look, as they do provide some very useful information. For some of you that have joined us for other webinars, you may notice we have a new platform, and I just want to make a quick announcement. You may see us, or you should see, a slide window that you can expand to fit your screen to make sure that you can see everything quite clearly. Additionally, there should be a box with a Q&A at the top of it. Obviously, that is for you to ask questions along the way. If you don't see that, there is a tab at the bottom of your page with a little yellow box that has a question mark in it. Just click on that and that'll open up the box. So I hope you enjoy the new format. Today's webinar is entitled Predictive Analytics with Revolution Analytics and Hortonworks, the Modern Data Architecture. Before we begin, I'd like to briefly review the format of today's webinar. Today's event will be approximately 1 hour long. We have two panelists that I'll introduce to all of you in just a moment. We should have about 15 minutes at the end of the session for Q&A, and this event is being taped and will be made available later on this afternoon at datasciencecentral.com. Again, please ask questions along the way. I'd really encourage our audience to participate. We will be reviewing those questions and asking them at the end of the presentation during the Q&A session. My name is Tim Madison. I'm one of the co-founders of Data Science Central, and I will be your host for today's event. I'm very pleased to introduce our panelists today, John Kreisa of Hortonworks and David Smith of Revolution Analytics. John is the Vice President of Strategic Marketing and a veteran from the enterprise marketing industry. He has worked on products at every level of the IT stack, from the depths of storage through to the insights of business intelligence and analytics. David is the Vice President of Marketing and Community at Revolution Analytics. His background is in data science, and he writes daily about applications of R and predictive analytics at the Revolution's blog. He was also named one of the top 10 influencers on the topic of big data by Forbes. So David and John, welcome to you both. Thanks for being with us today. Hadoop, being a disruptive data processing framework, has made a large impact on the data ecosystem of today. Enabling business users to translate existing skills to Hadoop is necessary to encourage the adoption and allow businesses to get the value out of their Hadoop investment quickly. R, being a prolific and rapidly growing data analysis language, now has a place in the Hadoop ecosystem. In today's webinar, we will discuss the trends and business drivers for Hadoop, learn how Hortonworks and Revolution Analytics play a role in the modern data architecture, and see how you can run R natively in Hortonworks data platform to simply move R-powered analytics to Hadoop. In today's event, we are going to be asking a few polls along the way, so I'm encouraging the audience to participate and just make a selection as you see it in front of you. The first poll is going to be, what stage are you at in looking into Hadoop? Production, evaluation, research, or simply what is Hadoop? So please, if you can, just take a moment, make a selection, hit submit, and then we will proceed to the polling results, and then we're going to start our presentations off with John in just a moment. So I'm just going to wait another moment here. Again, please hit the appropriate selection and then hit submit. And I'm going to proceed now. Very good. Thank you very much, everybody, for really participating. It's fun to see the results. So with that, John, I'm going to turn it over to you, and you can begin your presentation as soon as you're ready to go.
Okay. Thank you, Tim, and good morning, good afternoon to everybody, or good evening, depending on where you're listening from. What I'd like to do today is to talk to you about Hadoop's role in the modern data architecture. So we've got a couple slides prepared to help us with our discussion. And the first thing I want to do is talk about the existing data architecture. Most, if not all, organizations today have some form of this kind of architecture. They're collecting, at the bottom, existing data sources from transactional or other forms of structured data, bringing that into, storing it into their structured repositories, enterprise data warehouse, relational database management systems, scale-out MPP systems, and then analyzing that data through a range of applications and tools, whether they're business analytics tools, like BI tools, or through other modeling tools, or perhaps custom-built applications or packaged applications. But this stack is a very, very common stack, probably in almost all modern organizations today who are trying to process and run their business. Interestingly, though, there's been a kind of a pressure put on these organizations, put on this infrastructure, in fact, due to really growing volumes of data, right? Many of you have probably heard of the big data movement, and really that comes from growth in a number of different sources of data. It's net new data types. Principally, all of the growth, in fact, is in new data types, and it's often driven by machine-generated data, data that comes off of sensors, cell phones, other kinds of electronic sensors that are measuring various things off of production networks or transportation networks or what have you. But data that's actually coming off of machines represents a very large portion of the new data growth, and something that's putting this existing data architecture under a tremendous amount of pressure. In fact, by some analyst estimates, by IDC's estimates, data will grow, the total data stored will grow to 40 zettabytes by 2020. It's a tremendous amount of data that will be stored by organizations, and puts a tremendous pressure on this existing infrastructure. And that's where Apache Hadoop enters into the equation. Now, Apache Hadoop is an open source technology that is an additive component to the existing data architecture. And what it does is it allows organizations to cost-effectively capture and analyze emerging sources. So on the bottom right-hand side, you can see we have new kinds of data sources. These emerging data sources around sensor data, sentiment data, geospatial data are captured in Hadoop, in a Hadoop infrastructure. And that infrastructure sits alongside of the traditional infrastructure, relational, EDW, and MPP, and gives organizations a place to capture that data so that they can then analyze it, often with the same business analytics, custom applications, or package applications they're using today. But the important component is that Hadoop is a plus one, as they say in the open source business, something that adds to the existing infrastructure and complements the tools that are there. In fact, we believe very strongly at Hortonworks that Hadoop doesn't replace or disintermediate any of the existing technologies. In fact, provides net new capability and functionality to the organization to allow them to do new things that they couldn't do before, or to do things that they're doing today in a more efficient way. So just a single slide on Apache Hadoop. Apache Hadoop is an open source project, and it's governed by the Apache Software Foundation. It has a very, very liberal software license that allows anybody to download and use and modify that software. Hadoop is scale out. It runs in a clustered mode. It has a clustered file system that connects a bunch of computers together and make it appear as one big seamless pool of storage, and then has a distributed processing engine that runs across that called MapReduce. And MapReduce is a very flexible programming language that allows companies and users to program very complex analysis and run it on very, very large amounts of data across this scale-out storage system. You can learn much more about Apache Hadoop at the Apache Software Foundation, or, of course, at Hortonworks.com. So what are some of the drivers for this adoption? We talked about the data, but what are organizations trying to do? There's really two drivers that we see for adoption of this open source technology. The first is around modernizing the data architecture. the topic of this webinar today that we'll spend the vast majority discussing. And that's really helping organizations drive efficiency within their business, to be able to do things now more cost effectively than they couldn't do before. And they can actually run, for example, workloads on the appropriate infrastructure, so workload optimization within their data and within their data center. The second driver is around business applications, and this is about driving new opportunities, creating net new business applications and business analytics, providing new insight into customers and operations for a specific line of business that allows that business to generate more revenue, have better insight into customers, to take advantage of the data that they have. And all of it kind of emerges from those big data sets, whether they're existing traditional data sets or new emerging data sets around sentiment and social data, machine-generated data, and the like. In fact, let's double-click on the data sets and the types of data. So a lot of the opportunity that lies that Hadoop unlocks is in these new types of data. And we at Hortonworks see typically 6 different types of data that are being loaded into Hadoop. So the first is sentiment data. Right? That is data about how your customers or prospects feel about your brand or your products. And it's typically expressed in rating sites or blogs or tweets or some form or fashion where your customers and prospects are expressing their feelings about and sentiment about your data. But you want to understand and know that. It's very valuable to understand who's reacting to your products and how they're reacting. The second type of data is clickstream data. This is data that's captured off of the website, right? So almost all companies interact with their customers in some way through their website. So capturing and analyzing the website visitors can give you tremendous insight into what customers are doing, not just when they click on the button that says purchase, but what are the 5 or 10 pages that they saw or links that they clicked on before they actually took action on your website. It can give you tremendous insight, but you have to collect a lot of data. Clickstream data comes in a high volume. Sensor machine data, patterns and data streaming that's coming from sensors that are connected to machines, whether it's an automobile, a truck, a manufacturing system, a supply chain, wherever it might be in that overall system. That electronic sensor machine generated data also comes in a high volume, but can provide tremendous insight into the operations of a business, the inner operations of the machine. Geospatial data, geographic data, data that tells about the location of where a service is being consumed or where a service is being delivered or where a user is, can provide also insight into patterns of usage and allow you to look for new opportunities. Server log data, data that's looking into server logs that are coming off of applications or search engines or other kinds of systems that are serving information to users, allows you to look for things like security breaches and other kinds of anomalies. And then finally, the final bucket really is a kind of catch-all, unstructured, which might be just plain text or XML or video data or pictures, satellite images, you name it. That data also, when combined in particular with any of these others, provides a tremendous amount of value. So these types of data, these 6 types of data really represent where we see a lot of the opportunity and a lot of the value being gained from using Apache Hadoop. So, again, turning back towards the modern data architecture, the efficiency is really driven in the organization through adding Hadoop to your overall stack. So you can store data one time in a single centralized repository before you process or transform it at a very low cost. Hadoop is a low-cost infrastructure designed to run on commodity hardware. That means that you can capture all your data. We had one customer who went from capturing 1% of the data for 60 days to 100% of their data for a year. And they were only able to do that because of the cost and storage value of Hadoop. One of the ways that you see Hadoop being used, and one of the ways we see organizations referring to it, particularly large organizations like telecommunications companies and financial services companies, is as a data lake. Right? One central repository where data flows into and then is used as a reservoir for for various analytics, for driving new applications, for driving new insight. And in each of these cases, it exchanges data very critically. It's important that it exchange data seamlessly back and forth with the data warehouse and the relational database system as the data is processed. And this is very much infrastructure and driven by updates to the overall platform, looking to make that data platform within the organization more efficient. And this tends to be an IT-oriented or total cost of ownership-based decision, something that's driving the change in this level of the data system, this kind of in the plumbing of the overall organization. So Hadoop is engineered for interoperability. In fact, that's one of the things that Hortonworks very much focuses on in terms of trying to bring this open source technology to the market and to help it reach its full potential. It's critical that it interoperate with the systems that are available in the enterprise today. Right? The systems that the enterprises are using today are critical components of running those businesses, and Hadoop has to interact with those systems and be available to run on those platforms that the organizations are using in order for them to get their value out of it. So you can see some logos here, just representative of the kinds of data systems that Hadoop has been engineered to interact with and interoperate with in order for it to get value. You may see tools that you use here, including our co-host with the webinar today from Revolution. The system is designed to interact with these tools seamlessly, allowing you to take advantage of this technology. And in fact, we really think that there are three key requirements for the adoption as a component of the modern data architecture to help organizations modernize and take advantage of Hadoop in order to get the operational efficiency advantages that you can get out of Hadoop. And there's three things. One is that it must be deeply integrated and interoperate with the existing technologies today. The previous slide that I just showed, it must take advantage of and enable you to access the data that's stored and processing capability that's available inside of Hadoop. The second is skills. You have to be able to leverage the existing skills, whether they're data management skills, data processing skills, administrative skills, analysis skills. You have to be able to take advantage of the skills that you have today that you've developed in your organization in order to take advantage of Hadoop. And you're going to hear more about some of the skills when we move on to the Revolution piece of the presentation. But integration and skills are two key components. And then finally, Hadoop and a modern Hadoop platform, as delivered by Hortonworks, has to have the key services to make Hadoop easy to run, easy to use at scale. So it has to have platform services that allow it to run and allow it to be a reliable piece of the infrastructure. It has to have the operational services, meaning that you can deploy and monitor and manage the infrastructure within your data center. And it has to have the other key services around data access. So integration, skills, and key services are three requirements that we very much believe and see that Hadoop has to have in order for it to take its role in the modern data architecture. And that's really one of the things that we're focused on here at Hortonworks, is helping drive and deliver on these three key requirements. So what about taking something like R and putting that into the modern data architecture? Well, R interacts with a lot of different components within the stack. And you can see that it both interacts with the traditional systems and the traditional repositories, but it also runs in Hadoop. It also is deeply integrated into this infrastructure so that you can take advantage of it at that data system layer to do the processing deep within Hadoop. And you'll hear more about that from my co-presenter David in just a moment. But R also is accessible from the packaged in applications and business analytic tools that you use within your data center, and it's also accessible through the tools that you use to build and develop and deploy applications on top of Hadoop. So with that, I'd like to turn it back over to Tim to have our presentation continue.
Great, thanks so much, John. Very good presentation. So as John mentioned, our next speaker is going to be David Smith from Revolution Analytics. But before David begins, we have one more, or not one more, but this is the second of three polls we'll be asking today. So this one is, which of the following best describes your use of R and Hadoop? We have R and Hadoop in production, or we are testing R and Hadoop. We have started to investigate, but nothing is implemented, or no current plans. If I can ask the audience again for their participation, please, to make a selection and then hit the submit button on your screen there. And then I'll just wait another moment, and then we'll proceed to the poll results, and then we'll have David begin his presentation. So, okay, hopefully everybody's had a chance to make their selection, and here we go. Very good. Again, thank you for participating in these polls. We really do appreciate it. So, David, when you're ready, please begin when you'd like.
All right, thank you, and thank you, John, for the introduction. Really interesting to see in the poll here. We do have, about 16-70% that are currently using R and Hadoop or are testing it. But the really interesting thing to me, 58% of people say they've started to investigate using R and Hadoop together, and that really reflects the kind of things that I've been seeing in my role as VP of Marketing and Computing at Revolution Analytics in companies, looking at using R in conjunction with these data stores. It's a really, really exciting time to be a data scientist today. As John had explained, there are just so many new types of data and data applications that are enabled by these massive amounts of storage through the Hadoop ecosystem. I mean, just things like, just 2 or 3 years ago, if an airline wanted to understand how consumers felt about their particular product, they had to do a year-long survey with Consumer Reports, sending out surveys to people, gathering information from, say, a few hundred consumers, which would drive the annual rankings of the airlines. Today, airlines can ingest data from social networks like Twitter and LinkedIn and Facebook, actually look in real time what people are saying about the airlines as they tweet about them, analyze the content of those tweets, and use that to create a real-time ranking of what people are thinking about an airline today, as opposed to waiting a year from the results of a consumer survey. I mean, it's just one example of the revolution that's happening in terms of the data that we're collecting. I mean, just to give you another example, video games. I mean, this is a data source that really didn't exist a couple of years ago, but is now generating more than 2 terabytes of data every year. And now video game companies are able to do things like analyze player performance in individual games, optimize maps, figure out where people are running into bottlenecks, and also enable the online store and optimize the transactions that support the revenue model behind a lot of these games today. Brand new industries, brand new data types, but how do you convert these new data sources into actual insight, into the actual analyses that drive these types of decisions? That's where R comes in. Now, if anybody's not familiar with R, it's an open source project that's been around for around 15 years, used by data scientists to make sense from data. It's actually a programming language, an object-oriented language which is designed by data scientists for data scientists to do statistics, mathematics, and all those types of data science operations that are behind getting insight from data, whether that's data exploration, data visualization, but most importantly, the statistical modeling and the predictive algorithms that are behind a lot of those insights that I was just talking about. One of the great things about R is, as it's an open source project, an enormous community has formed around people using R today. It's today the most widely used software for doing statistical analysis and data science. There are more than 2 million users around the world who have shared their expertise in all sorts of domains. Whether that be in the financial services sector, whether that be in pharmaceuticals or in manufacturing or marketing or gaming, as I was mentioning earlier on. They've all done analyses with the R software and have also contributed back the results of their work to extensions to the R ecosystem. Something called packages that people contribute that add to R itself. There are now more than 5,000 packages available for R with specialized methods in all those domains I was talking about. And one of the great things for companies that are thinking about implementing new data science techniques upon the data that they've already stored in a Hadoop ecosystem is that new graduates at universities that are learning data science, learning statistics, learning machine learning, they're taught R at school. So there's a steady stream of new graduates coming out of the system ready to actually get their hands into these Hadoop data stores and get information and insight out of it using the R language. Now, we here at Revolution Analytics are the worldwide leader in services support and consulting around open source R. And we also have a product called Revolution R Enterprise, which extends R to make it work with big data. R traditionally hasn't been thought of as a big data tool because it was designed to be an in-memory system to enable that flexibility and interactivity which is essential to the data science process. But one of the things that we've done with open source R at Revolution Analytics is to extend it to work with big data as you find in Hadoop, so you can apply those same types of exploratory data analysis techniques and modeling techniques to much, much larger data, but still working within the R ecosystem. Performance, of course, is a big issue when it comes to working with big data. R traditionally has been thought of as a single-threaded application. One of the things that we've done at Revolution Analytics is to make R work in parallel, so you can scale it out into parallel processing systems for high-speed computations on these large data sets. As I mentioned a moment ago, R is amazing in terms of the community support it provides. We augment that at Revolution Analytics by providing commercial support for people that are using R in production environments where they rely on it for mission-critical applications. And of course, everything that is available to an R user from the open source R community, those 5,000 packages, the exponential growth in the R users, that applies equally well to somebody using Revolution R Enterprise because it's 100% R and more. You can use all of those open source R packages and take advantage of all the innovation and scale coming from the R community. So in summary then, Revolution R Enterprise is the only commercial big data analytics platform based on that open source R language I was just talking about, bringing high performance analytics and big data analytics to R across all sorts of platforms, including Hortonworks Hadoop, as we'll talk about in just a moment, plus database platforms, cluster computing platforms, and regular servers. We make it easier to build and deploy R into production applications so that they can be enterprise ready to support those types of insights I was talking about at the beginning of my section. So let's talk a little bit about the traditional way that R integrates with Hadoop, as John was talking about earlier on. Of course, one of the ways you can work with data in Hadoop is to extract it out from the Hadoop cluster into a dedicated analytical server where an R user can work with the data directly and do exploratory data analysis, statistical modeling, and so forth. Now, of course, there are going to be a couple of compromises in that process. As John was talking about, Hadoop stores massive volumes of data, and it doesn't make sense to move that entire corpus over into another system simply for analysis. So there's going to be some kind of data distillation process happening at that point. Fortunately, R is very good for that. And in fact, there's an open source project called R Hadoop, which was created by Revolution Analytics, which brings the open source R engine, that single-threaded in-memory engine, into the individual nodes of the Hadoop cluster. That enables it to use a lot of the in-memory applications of R, things like being able to do sentiment analysis on a single tweet, to process a large body of Twitter data to extract out the sentiments associated with that airline application I was talking about earlier on. If you're a skilled MapReduce programmer, you can write in the R language and use those R packages to extract out little bits of information from that huge volume of corpus data within Hadoop to create a smaller structured data set, which is useful for now analyzing on a separate server system. And of course, you can use all of the functionality of R to do that, to do exploratory data analysis on that distilled data, to do model prototyping and model development that ultimately you want to bring into some kind of production system with big data to support an online application. Now, when it comes to doing data science on big data, what are the types of things that you need? These are all the applications that we have brought to open source R to work with big data to support that process for the data scientist working with R and Hadoop. For example, we've introduced what we call the R data step. This enables data scientists to work with enormous data sets in the Hadoop environment, but use all the tools provided with R to process and distill and filter that data to make it ready for analysis. Anybody who's worked in the data scientist milieu knows that 90% of the process often is simply accessing, aggregating, cleaning, and filtering the data. And this R data step allows the R environment to work with big data to generate those data sets you need for analysis. Once you've got those data sets ready, you can use our big data tools to do things like descriptive statistics, calculating means, medians, quantiles, exploring the data numerically. And of course, we often want to explore the data visually as well. So we provide big data visualization tools, which you can use to process these large data sets as well. Simple statistical tests, to support things like A/B testing for big web traffic data is all supported in there, as is sensible sampling and survey sampling type techniques, and simulations if you actually want to generate data or have a look at what-if scenarios. All those are provided in Revolution R Enterprise. But probably the most important components are the last two on the slide here, machine learning and predictive model. These are the underlying intelligence engines that drive all the insights that we were talking about in terms of data. If, for example, you want to figure out, of all the particular activities that a consumer might do, whether that to be in-store, online, on loyalty card data, interacting with emails and so forth, you want to build a predictive model based on logistic regression to actually figure out what are the particular triggers that drive an individual consumer to convert. This is a very complicated model, but it's something that an R programmer is very, very familiar with today. Now you can use that same modeling technique within Revolution R Enterprise, but apply it to very, very large data sets. That also extends out to things like regular regression, tree models, stepwise regression, k-means clustering techniques, all those modern statistical and data mining algorithms that you need to convert these massive data stores into insight. The actual way we at Revolution R Enterprise have converted those models to work in the big memory context is to create something that we've called parallel external memory algorithms. The big insight here is that rather than trying to bring all the data into memory at once, which for a lot of the applications we're talking about here just simply is not possible, instead we figure out how to partition the data into smaller chunks, which can be processed in parallel. Now, the traditional way of doing that is to do it on a massively parallel server, say a 16-core or a 32-core server. You can split the data up into those individual components, and in parallel use each individual CPU core to process that data and then aggregate the results into a single result as if you had just been working in all the data in memory at once. Rather than bringing the data all into memory, these parallel external memory algorithms actually stream the large data set from disk into the individual CPU cores, but that's all transparent to the individual R programmer who's just running a single line of code on their machine. This exact same process translates directly over into the Hadoop environment. But now, rather than thinking about an individual CPU core as being the parallel processing element, we use an individual node within the Hadoop cluster as being that parallel processing element. But the underlying algorithm is the same. We partition the data now onto the individual nodes of the Hadoop cluster. In parallel, each node is running those computations to do, the predictive model, say logistic regression, and then a master node sitting on the Hadoop cluster aggregates all those results into a single analysis, which is then used by the data scientist as before. Now, behind the scenes, this parallelism, this partitioning is being done with MapReduce. But again, that's all transparent to the individual R programmer who simply is running an R command on a big data set that they know is living in the Hadoop HDFS file system, and then the results are coming back directly to them. So to show you a little bit more about how that fits into the Hadoop ecosystem, now we have the Revolution R Enterprise engine, including the open source R engine, running on each of the elements of the Hadoop cluster, using a MapReduce implementation. You can do production data distillation. So again, going back to that tweet distillation example, you can use the same technique as we did before to process massive amounts of data using all the techniques that are available in R to generate a distilled data file. But now, rather than extracting that file out into another system, we can leave that distilled data directly in HDFS, sitting on all those Hadoop cluster nodes. And now a data scientist working, say, on an individual laptop or a workstation with Revolution R Enterprise can connect to that data sitting on Hadoop, do analytical processing using the R language, but they're not using the processing capacity of their laptop, of course. They're actually using the processing power of Hadoop and the data that's sitting in Hadoop to do that computation, and then just having a look at the results directly on their own system, their laptop or their workstation. One of the real advantages of this is that not only does it enable the exploration and data modeling process by speeding up the process for the individual user to get access to data, to explore data, and to build that predictive model, it also makes it easy to put that model into production because they can use that same code running directly within the Hadoop environment in an automated fashion to run those models on a regular basis. As we all know, as new data comes into the system, we need to re-estimate those models to get better predictions, and then we can automate that process by sitting the data directly in the Hadoop ecosystem. And then when it comes to scoring those models, this is the real-time application of actually choosing which customers to market to, or which object in a game to offer to a player in real time. Those scoring applications can run directly within the Hadoop system using the same code again in R, running directly on the Hadoop nodes. So in conclusion then, with Hadoop and R together, what you have now is the Hadoop platform not just as a data storage environment, but as a highly powerful computational engine for R programming. So you can use all those Revolution Enterprise parallel external memory algorithms, big data applications for processing and filtering data, exploring data, and most importantly, predictive modeling that you've been using on an individual machine. Without changing the code, you can actually have those same computations running directly on Hadoop using the processing power of Hadoop. For an R user, this is very, very simple. If you've been using R today to build predictive models using pretty much the same R code, you don't need to manually parallelize the problems. You don't need to think about breaking up the data. You don't need to think in MapReduce. That happens all behind the scenes for you using the algorithms that we've written and integrated into the R library. Importantly, if you've currently been working with R and Hadoop by extracting data from Hadoop, you'll know that especially when you're working with big data sizes, just extracting the data can take a long, long time. Now you can just leave the data directly in the Hadoop environment, completely eliminate the cost of that latency of moving the data, and work with the data where it lives. And you can expand your processing capability for R itself by using the Hadoop nodes that you have already as processing engines, computation engines for R in parallel. And with that, let me turn it back to the moderator.
Great. Thank you very much, David. Great presentation. So we're about to enter into our Q&A phase, and lots of questions have come in. I really appreciate our audience for being so interactive. We do have one final poll that I would like to ask everyone to participate within. The question is, which of the following would you most like to accomplish with R and Hadoop? Build a model to be put into production in Hadoop, build a model to be put into production elsewhere, create new data from Hadoop data to supplement an existing analytics process, or simply something else. If you could please just take a moment and make the selection that's most appropriate to you and hit submit. We will proceed here and then move into the Q&A portion of our event today. Okay, so hopefully everybody's had enough time. Here we go. So John and David, before we go into the next slide, do you guys want to comment on this, on the results here?
Thanks, Tim. I mean, I think it's interesting that, if I look at this, there's quite a few who are looking at the combination of R and Hadoop together, right? We've got build a model to be put in production in Hadoop, which is great. That's almost 37%. And then create new data from Hadoop data to supplement, and that's 37% as well. So I mean, it's very interesting intent in terms of R and Hadoop. I don't know, Dave, if you want to comment.
Yeah, I agree. I mean, I think that what stands out to me in this is, almost 75% of the respondents here talking about either putting models into Hadoop or creating new data from Hadoop to supplement an existing process, which itself is a production application. So I think people are really looking at the Hadoop infrastructures they have today, taking it beyond simply using it for data storage and actually using the computational power that's available to them to either use directly within Hadoop for model building or to supplement other processes, which is, just really adding to the value of the Hadoop infrastructure they have already.
Yeah, these polls are always very interesting. So audience, thank you again for participating in them. So moving into our Q&A portion, the slide that you see up currently, while we're going to be asking the questions, I'm going to leave it there so you can copy down the information if you'd like to visit Revolution Analytics to get more information, as well as Hortonworks and Sandbox. So the first question for today is for you, John. It's how do we interoperate the existing database and Hadoop database?
Yep, great. Thank you, Tim, and great question. I'll try to go quickly. I know we have a lot of questions. This is a relational database or an EDW can interrupt with Hadoop in a couple different ways. Firstly, there's an ODBC driver that's a component.
John, are you still there?
I think we may have lost John there.
Sorry, I think we lost John. So let's move on. David, you're still on the phone, so let me ask you this question here. Kurt, perhaps you can help figure out what happened to John's phone there. When will Revolution Analytics leverage the OS 10 platform?
So the question there is about when Revolution Analytics will support Macs. And the answer is there's no plans in the meantime. I'm a Mac user myself, and I would love to have Revolution Enterprise on the Mac platform. But just when we're seeing the demand for production environments, the main demand we see are on Windows and Linux, and they're the platforms that we support today.
Okay, very good. Until we hear back from John, I'm going to ask a couple more questions I think be appropriate to you that have come in. So David, is it ever a good idea to extract data from Hadoop and analyze it on a separate server?
Sometimes it is. Especially when you're in the exploratory data analysis phase, it can be worthwhile to figure out a data distillation strategy, extract the data out into a separate high-performance server where the data is sitting local, and then start doing the analysis there. One of the advantages of doing that is that especially if you're going to be working with data that's remote across the network, it can slow down sometimes the iterative process of actually trying out a different model, trying a different visualization, and that's so important to the data science process. You really want to interact with the data, be able to try out different models, different techniques, different subsets of the data to really optimize the predictive power of the model. And in that environment, it really helps to have the data close to you personally and on a system that is high performance. Now, that changes, though, when you get into a production environment. Once you've got that model set up and ready to go, you want to put that into a system where that model is running automatically and running regularly. Now, if for you, as a data scientist in the exploration phase, it took, let's say, 2 hours to extract the data to a separate server, that's a one-off hit. It's somewhat annoying, but you only have to do it once, and then the data's all there for you to play with. But in a production system, that 2 hours can be a killer. And if you can actually leave the data in the environment where it lives, in Hadoop, and have the computations run directly on the data where it's staying with the Revolution Enterprise PIMAs, you can eliminate that latency, eliminate any potential failures that might be related to moving the data around on a regular basis, and just optimize the whole production process. So to summarize, sometimes it's often worthwhile to do the exploration on a remote system that's close to you, but then you can take exactly that same code in R that you used on the prototyping phase, run that in production in Hadoop using the architecture we've just talked about. So very low cost of transferring it back and don't need to write in another language.
Okay, very good. John, are you back with us?
I am, Tim, and sorry about that. Don't know what happened, but I'm back.
That's okay. You were in the middle of your question. Do you want to complete your thought process?
Certainly. Thank you. So just back on connectivity between Hadoop and relational database and relational systems, there's really 3 ways you can do it, multiple, at least 3 that you can do. One is an ODBC driver that's part of Hive, or use a commercially available one from a company like Simba. You can connect using a framework developed specifically using an open source project called Scoop for high-speed node-to-node interconnectivity, or you can go directly against the file system using something called Web HDFS, and that allow the REST database system to access the file system directly. So a couple different methods for exchanging data back and forth with a traditional relational system.
Okay, great. So another question for you, John, is as Hadoop is an open source, is there any risk associated with data security? The attendee is asking that there might be additional security layer that's needed on top of the ecosystem to protect your data. Can you shed some light on that?
I don't think there's any risk because it's open source to data security. Certainly, there is basic Hadoop security within Hadoop through Kerberos and other security essentials. It's certainly not as mature as the security capabilities that are in a relational database system. It's something that the open source community continues to work on and evolve through things like a project called Knox, as in Fort Knox. So there's ongoing efforts to continue to improve the security, but there's nothing that comes specifically from the fact that it's open source. It's just a technology that's continuing to mature.
Okay, very good. David, they're relative to, or related rather, to the question we asked earlier about the OS 10, there's another platform question here for you. Does Revolution R Enterprise work on any operating system?
Yeah, as I mentioned in the last question, Revolution Enterprise is supported on Linux platforms, 5 and 6, and also on Windows platforms.
Okay, very good. Quick answer for that one. John, here's a question for you. I used the sandbox from Hortonworks. Hold on a minute. I think this is a sort of fragmented question. Let me find another one here for you. Let's see. What are some of the top industries using Hadoop?
Yeah, good question. So, we see Hadoop across a very broad range of industries. But it's certain that the early adopters of the technology were in the kind of big web properties and companies that interact with their customers via the web. So we've certainly seen it with retail companies as early adopters, companies who, again, are trying to get that retail web channel going and optimized. We've also seen it with telecommunications telco companies as they try to store and analyze call data record information, try to understand patterns and better serve their customers, as well as financial services organizations that may sound counterintuitive. They've been very early adopters of the technology. And then, continuing kind of trailing off from there, we're seeing the healthcare industry very interested, government very interested, manufacturing very interested. So it's very, very broad, the adoption. But it started with in the early days with big web properties, then retail, telecommunications, and financial services.
Okay, very good. I have another question for you here, which is the other part of the question I started to ask. Are there some sample code to run on the sandbox for Hortonworks?
Yeah, so you could use open source R against the Hortonworks sandbox today, but Revolution are working on a tutorial, much like our other partner tutorials in the partner gallery there, that would enable you to use Revolution Enterprise against the sandbox and allow you to get the experience of those. I don't know if Dave wants to comment on that, but that's in process.
Yeah, that's right. Revolution Enterprise works with the sandbox implementation. So if you'd like to try it out using Revolution Enterprise on the sandbox, please just click the Contact Us link on the Revolution Analytics website, and we'll be happy to get the software in your hands to do that.
Very good. So, David, here's a question for you. How did you scale out R? Did you implement that in Java? What are the most common problems you experience when you integrate R with Hadoop?
Yeah, so good questions. The way we implemented these algorithms is we actually created an add-on library to R. It's called Scalar, which is actually behind the scenes, basically doing replacement implementations of some of the standard R functions to do things like data processing, statistical modeling, logistic regression, and so forth. Behind the scenes is actually written in C++, which is nice because it lets us port those same algorithms onto different platforms. Probably the biggest challenge when it comes to creating those algorithms is to make them work in a distributed fashion. I saw there were a couple of other questions in the list there. People were asking us, like, how do you deal with, the different parameter estimates that come on the different nodes? That's what we have implemented with our parallel external memory algorithms. We figured out a way to actually do something as complex as logistic regression, running little pieces in parallel across the individual nodes, and then to combine the results back together as if you had run, one big analysis on one big chunk of data. Now, again, from the point of view of the R user, you don't need to worry about any of this. All you do is point a logistic regression using a function for those people that are R programmers, pretty much identical to LM, on a data file that is sitting in Hadoop using the same formula syntax that you use in R, and then say go. And our algorithms take care of all the details of partitioning the data, running the individual analyses, and then reaggregating the results. It's all completely transparent to the R user.
Very good. So there's a question for you. How is data stored in Hadoop? Like data is stored in tablets and RDBMS. How does R interact with data in Hadoop?
Maybe I'll start with just the simple version of that. From the perspective of the R programmer, you're really just working with a file. In the same way that you would work with a CSV file or an XDF, which is our big data out-of-memory file that we have with Revolution Enterprise. You're just pointing a statistical model at a file that has rows and columns upon which you do a statistical model. Now, behind the scenes about how that file is stored in HDFS, I'll turn over to John.
Yeah, thanks, David. It's a good question. I mean, the storage piece or component of Hadoop is called the Hadoop Distributed File System, and it really is a file system where you can store any kind of file in its native format, just like you can on your PC. So whether it's video in its native video format, XML, a database dump, whatever it happens to be, you can store it in that native format. It's one of the strengths of Hadoop in that you can store any kind of data in any native format and then proceed to transform that data with the MapReduce engine. So it's really whatever format you have is the format you can store, and then that gives you the flexibility to access that data and transform it into whatever you need it to be.
Very good. Okay, I have a question I think applies to both of you. Is there any examples that you can point to that integrates Hadoop, R, and data visualization?
Yeah, I think I can give a good example of that. There's a company called DataSong. They're a marketing services company that work with big retailers, like Williams-Sonoma. And if you're sort of in the retail business, one of the big questions you have is, of all this money I spend on marketing, whether that be email or TV advertising or in-store or loyalty programs, what's actually effective in terms of actually driving people to buy my product? There's so many new data sources now, which they actually work with the retailers to bring into the Hadoop environment. That's clickstream data from the website, that's transaction data from the loyalty card system, that's advertising data from ad click networks, plus demographic data, which comes from data providers. Aggregate all those massive data stores together in Hadoop, and then apply a predictive model, in this case a logistic regression model. Actually use a survival analysis where what you're trying to measure here is, traditional survival analysis for the data scientists out there is about, time to die. It actually comes from the biopharmaceutical space. But instead you measure time to buy. What are the influences that cause somebody to buy quicker? Very advanced statistical model running in Hadoop with Revolution Enterprise on those data stores. And of course, visualization is a big part of that as well. Being able to present to a marketer at a big retailer, here is the incremental effect of doing, say, a catalog. And, over the first week or so, you'll have some kind of effect, but that'll die down over the next couple of months as people sort of stop looking at the catalog. And you can represent those things visually very easily using R's very strong visual display techniques.
Very good. Thanks.
That's a great answer.
John, you have a comment? Or?
No, I was going to say it's a great answer. I don't think I have anything to add to that.
Okay. Another question is, David, I think this might be for you. Can you run any R function or package on Hadoop? And you
can run. Yeah, that's a great question. So, for example, in the data step that I was talking about, you can use literally any R function to do that processing. And that works well because in that environment, you're just using the in-memory capabilities of R, but you're typically only working with one record at a time. So memory really isn't an issue in that environment, but it's great for doing things like sentiment analysis on a single tweet, as I mentioned earlier on. But when it comes to data applications where you need to work with all the data at once, and the key example here is predictive models, what we've had to do at Revolution Analytics is to re-implement existing R functions as parallel external memory algorithms. We have more than 80 of those functions today, not replacing, but complementing most of the stuff you have in open source R. So again, from an R user's perspective, it's completely transparent, using much the same functions as you used before, but we can't do everything that's in all 5,000 R packages. We're working on the ones that are the most requested and the most popular.
Okay, very good. Another question is, how secure is Hadoop storage? So a couple of questions have come across this way compared to maybe, say, something like Oracle. Can you give some details on sort of just the general security concerns?
Yeah, this is John again. I mean, I think we talked about it a little bit before, but Hadoop has security built into the file system. There is some also basic user level security for the various query engines like Hive and the other that gives some control over the data that's stored within Hadoop. So, for example, the on-file storage is Kerberos. You can also use encryption and other methods to further secure the data, but it's not as mature as an Oracle technology. Heck, that technology is 30 plus years old. So it's but it has its downfalls and its costs. So the idea for Hadoop is that the security will continue to mature and get better. Lots and lots of organizations are using it today for processing a very wide range of data, but you have to kind of dig into the specific details of what you want to do and what kind of data you have to kind of understand if there's risk related to that kind of data in Hadoop.
Right, okay. Thank you for that answer. One more question, and this seems to be always a good question that comes up in these events, and as we even saw in the polls, there are plenty that are interested in, they're learning more about how to implement these new technologies. And the great question is always, how does one get started? With both of you guys, I think it's appropriate to wrap up in a sense of, you covered all the basics, but what does someone do if they're just really starting out or they're at that sort of first stage? David, why don't you start us off?
Yeah, also then, I mean, as with anything, the best way to learn it is to use it. When it comes to the R language, if you have any sort of programming experience at all, it's pretty familiar just in terms of its constructs. We do provide some getting started resources on our website at revolutionanalytics.com. If you click the What is R button on the left-hand side of the screen and then click on Additional R Resources, we provide some getting started guides. There's also some great video tutorials from Coursera, which are actually running just now. So you could hop on one of those Coursera courses, and that's a great way to get up to speed with the R language.
Great. Thank you, David. John?
Yeah, thanks, David. It sounds like some great resources. In terms of getting started with Hadoop, the first place we always point people is towards the Hortonworks sandbox. That is referenced on the slide that you see in front of you. That is a single node virtual machine, runs on a couple different virtual machine implementations that you can easily download and use. And it has, I think to date, there's 14 or 15 published tutorials for how to use the various components of Hadoop and how to use it for various kinds of analysis. There's partner tutorials for how it interacts with various partner tools, as you heard. You can use it with Revolution Analytics. And that's really the place that we urge people to start if they really just want to learn even the basics of Hadoop, because the tutorials really walk you step by step through how to use the basic components of Hadoop and then allow you to move on to more complex stuff. Outside of that, we provide training from Hortonworks that allows you to get in a classroom environment if that's more appropriate for you. And as well, there are tutorials and other resources on hortonworks.com.
Great. Thank you both. Some really great, thoughtful answers to some very good questions along the way here today. For those of you that did ask questions, we had an awful lot that came in. I want to make sure you are rest assured that these questions are being delivered directly to both John and David, and they will be replying to you so you get those answered. I have just a couple of quick announcements to make, to please mark your calendars for October 8th and our next Data Science Central webinar. Implementing a Strategic Archive Solution, the Cure for Data Growth Insanity, which is sponsored by eVault. Also, as I mentioned earlier, this event is being taped and will be made available later on this afternoon at datasciencecentral.com and can be found on the lower right-hand side of the homepage in the video section. This brings today's webinar to a close. I want to thank our audience for their attendance, their questions, their participation in the polls today, and a special thank you to both Hortonworks and Revolution Analytics for sponsoring today's event, and to both John Kreisa and David Smith for their insight and perspective on today's topic. My name is Tim Madison, and I'm very pleased to have been your host for today's event. I look forward to seeing you all again on October 8th. Good day.